All right, as we move into our next section, we're going to be looking at the theorems and postulates that make up the bulk of Chapter 3. So many of these we've already highlighted as part of our class notes. So I'm going to move through them fairly briskly for your notes. If you're filling them in as you work, you do want to look back at the previous notes to see what you can fill in without needing this roundup for all of these, because there's a pretty good collection and a lot of potential writing ahead of you. So I'm going to try to minimize how much I put on the board in order to reference the key ideas you should be looking back at. Now, first we had a collection of postulates and theorems that were built around the idea of two lines being parallel. So there's our sketch in order to have our conversation. And specifically here, I'm talking about the corresponding angles postulate and then the three theorems that follow from that. So, for example, I might talk about the corresponding angles postulate itself, which we know says that if two lines are congruent, if two lines are parallel, which these two lines are, so I have my two parallel lines. Oops, give me my arrow. Corresponding angles. And again, we did say these lines were going to be parallel to make this work. They all start with the same idea. If two parallel lines are cut by a transversal, so I can write if, I won't write the word, I'll write the actual word. So if two parallel lines, so that's where they all start. Then I have lots of parallel lines. Come on. There we go. So if two parallel lines are cut by a transversal, then and everything that comes out of this, we know the corresponding angles are congruent. Well, actually, let's write the word out. Are congruent. We also know that alternate interior angles congruent again. We also know that alternate exterior angles are going to be congruent. Now, if you think about what we've got so far, the corresponding angles postulate is the one that says the corresponding angles are congruent. Alternate interior angles postulate, congruent. Alternate exterior angles, congruent. And they all start at the same idea. If two parallel lines are cut by a transversal. And lastly, we have same side interior angles. And they, oh, I had the wrong pen. No wonder that looks weird. Same side interior angles. They're going to be supplementary. So as you look through the list of these, think about what each of these theorems says. The corresponding angles postulate is the one that would pair our corresponding angles. So I'll make a little black circle here, say that's what we're talking about, which would be angles like these. They're going to be congruent to each other. And the alternate interior, we'll use red, might be this angle and this angle, the angles that make like a Z shape. The alternate exterior would be maybe these guys. Now notice how they're on opposite sides of the transversal. Alternate angles are on opposite sides of the transversal. And then finally, same side might be this angle here and this angle here. Those would be my same side interior angles. So we have four theorems. All of them start at if two parallel lines are cut by a transversal, they all end with some property therein related. Now, what I'm going to do, I'm going to take all of this, I'm going to copy it. We're going to go put that on another slide. And on this slide, what I'm going to do is I'm going to make a copy of that slide, because all we're going to do is we're going to change it. There we go. Bing. What we're going to do here is we're going to take this word if, and we're going to throw it over here. Then we're going to add the word then. Let me rewrite that whole section. I'm going to write then the lines are parallel. Lastly, I'm going to come over here and I'm going to take these arrows off, because I don't know that they're parallel as part of this. That's my conclusion. Now these are all of my converses. So if you think about what we're talking about, the converse of corresponding angles postulate says if corresponding angles are congruent, then the lines are parallel. If alternate interior angles are congruent, then the lines are parallel. So the converses start with the property and lead to things being parallel. Now, there's not much more left to cover as a part of our roundup. We have what's called the parallel postulate. Now, this gets covered a little bit late in the notes, and it's a little sad because it's really important, but we don't use it in any of our proofs because it's very hard to use at the level we're working. It says this: if I were to take a line and put a point not on that line, that I can only draw one line through that point that's parallel to this line. So it says through point P, not on line L, there is exactly one line that is parallel to the other line. Now, the proof of this involves doing what's called an indirect proof. I would have to say, well, what if there were two lines? Oops. Let's put that back on solid for my writing. Let's grab my line tool. Let's make a dotted line. What if there was a second line that was parallel? And then you have to look at the implications of that. And unfortunately, many of our implications still work. There's a lot of things we can show that are still true because so much of what we know and don't know about parallel lines come from this postulate. But again, the proof is very hard to do, and we don't use it in many proofs at this level. So I'll put it over there. So the parallel postulate is the one that says, hey, I can only draw one line that's parallel through there. Theorem 341, if two intersecting lines form a pair of congruent angles, then they form a corresponding pair of congruent angles. No. Yeah. Two intersecting lines form, sorry, I'm misreading. 341, if two intersecting lines form a pair of congruent angles, that's all it says. So, oops, let's get a solid pen going again. Then the lines are perpendicular. So again, I want to say that those are right angles. So if they're congruent, they're right angles. For 341, the perpendicular transversal theorem, and 343, you want to go back to the most recent set of notes on 3.4 because that's pretty much all the notes are. The perpendicular transversal theorem, if in a plane, if a transversal is perpendicular to one of two lines, then it is perpendicular to the other line. So there's a line, there's another line. It says if a transversal, so there's my transversal, and it's saying if it's perpendicular to one, then it follows it must be perpendicular to the other. And theorem 343 is its converse, which says, hey, if I know these are perpendicular, then I know the lines are parallel. So if two coplanar lines are perpendicular to the same line, then the two lines are parallel to each other. And that covers all the major theorems in chapter 3 that you're going to need for unit 2. So it gives you a chance now to bring these all together into one spot and get these outlines filled in. All right, good luck. Remember the test. It's Friday.